Hello, my name is Samantha, and welcome back to another Girls in STEM lesson. Last lesson, we talked about nested for loops. Today, you'll be introduced to arrays and some ways that we can use for loops to work with them. I'd like to introduce Sarah, who will be the instructor for today's lesson.
Hello, my name is Sarah, and I will be your instructor for today. We'll start our lesson with some review problems from last week's lesson on nested for loops.
We'll need to set up Replit for all of our warm-up and practice problems today. We can start by creating a new Replit called Lesson 7. You may pause the video here if you need to. First, let's do a quick review of nested for loops. A nested for loop means that we have a for loop inside the body of another for loop. When you nest two loops, the outer loop will repeat the inner loop and the code inside. If you want a more in-depth review of nested for loops, we recommend that you watch our previous video before continuing this one. For today's lesson, our warm-up problem asks us to write a program using for loops that print all the numbers from 1 to 100 that are divisible by 11 and or 13. For our hint, remember that when we check if a number is even or odd, we find the remainder when divided by 2. Similarly, we can use the modulo to check if the number is divisible by 11 and or 13. The question asks us to use for loops that print all the numbers from 1 to 100 divisible by 11 and or 13. To do this, we can create a total of 3 for loops that each check for the following conditions: if numbers are divisible by 13, 15, or both. Within each for loop, we can use an if statements with a modulo sign to check if the remainder is 0. If the remainder is 0, we know that it is divisible by the divisor. We test this with each number from 1 to 100 and divide by 13, 15, or both to see if the remainder is 0. If that is true, that number will be printed. When printing out the numbers divisible by 11 and or 13, we can use the \n character to format the list neatly. Now, we'll move on to the topic for today's lesson, arrays. An array is a group of like-typed variables that are referred to by a common name. The variables in the array can be any type, such as integers, strings, booleans, and even scanners. Now, we'll discuss how to create arrays. We'll first introduce one-dimensional arrays. The general form for a one-dimensional array declaration is the type, followed by square brackets and the array name. The type refers to the element type, which could be integers or booleans. In our diagram, we have a one-dimensional array of integers. Keep in mind that this only declares the array and does not initialize it. Now we can initialize our arrays. The first way to initialize an array is to keep it empty, but give it a length. We can either have a two-step declaration or a one-step declaration. For a two-step declaration, we can first declare like we did on the last slide. Then in a second line, we can create an empty array by specifying the number of elements. In our example, we created an array called array A, which can store 5 integer elements. For one-step declaration, we combine these two steps to be in one line. The second way to initialize an array is to create an array literal. Array literals are used when the size of the array and variable types of the array elements are already known. They can also be used when you want to initialize an array with specific values. The syntax is slightly different than what we have for initializing empty arrays. In our example, we have the same declaration, the type, followed by the square brackets and the name. The initialization uses curly braces and gives the values inside the array. Now we can take a look at an example. What do you think that the code on the slide will do? Our hint says that the 1 in my array 1 stands for the index of the array, which holds the value we want to print out. The code on the previous slide would print out 2. Since array indexes start at 0, we'll take the second value in the array list, not the first. Indexes are how we access individual values of the array. This general syntax for using an array index is the name of the array, then the index you want to access enclosed in square brackets. Knowing this, what does the example code on the slide print out? This should print out 1, then 5 on separate lines. We initialize our array to the values 1, 2, and 3. Then we print the value at index 0, which is 1. On the following line, we change the value of our 0 to 5, and we print the new value. Now that we've gone over the basics of arrays, let's do some practice. For this problem, we're asked to create an array of integers. Then we'll print out the first 3 values in the array on different lines. The problem also gives us some sample input that we can test. You can pause the video here, work through the problem on your own, and resume the video once you have attempted or completed the problem. Here's the key. We'll first create our array with the sample input of the integers from 1 to 10. Since we want to print certain values, we'll access these values using the indices of 0, 1, and 2, and use a print statement to print the values to the console. In Java, recall that the first array index is 0, not 1. Thus, using index 0 will print out the first value of the array. What if we wanted to print out all of the values in an array? To do this, we could use a for loop to access the values at each individual index. Look at the example on the slide. We initialize an array called alphabet with the string values A, B, C, and D. Then, in the body of our for loop, we print the value of alphabet at index I. Since our for loop's lower bound is 0, which corresponds to the starting index of the array, and our upper bound is alphabet's length, this for loop should print out all of the values in this array. Note that the length function gives the length or size of the array. This next problem asks us to write a program that prints out every value in an array of strings, except for the first value. In the sample input, we have an array that contains the strings dog, cat, bird, and house. In the output, we will only print cat, bird, and horse. You can pause the video here, work through the problem on your own, and resume the video once you have attempted or completed the problem. Here's the answer. We can first create our array with the sample values. Then we could use a for loop to go through each value of the array, starting with the second value, which is at index 1, and ending once the loop iterations reach the array's length. With each iteration of the loop, the program will print out the value of the array at index I. Note that when we use a for loop to traverse an array, we need to make sure that the counter variable doesn't equal or exceed the array's length, since that will give us an out of bounds error. Just like how we can access array values using for loops, we can also change them, especially if the array values follow a pattern. Take a look at the example on the slide. What will this code output? This sample should print out the values of 0 to 9 divided by 2. This should give us a list of 0.0, 0.5, 1.0, and so on. We start by creating an empty array that will hold 10 floats. Then, in our for loop, we create a float called num and set it to the variable counter variable I. After that, we set the value of the array at index I to num divided by 2. Finally, we print each of these values. Our third question asks us to write a program that uses a for loop to create an array of the numbers 0 to 45 that are multiples of 5. Then print out all the values of the array. In our sample output, we see that we have 0, 5, 10, and so on, until we get to 45. You can pause the video here, work through the problems on your own, and resume the video once you have attempted or completed the problem. Here's the key. You actually don't need an array to complete this problem, but for the sake of practice, let's try it using an array. Since we know we'll have 10 values, we can first create an empty array of integers with length 10. Then we'll use a for loop to go through each value of the empty array and assign it a value. Similar to the for loops example, we can multiply our counter variable by 5, then assign that number to the value of the array at index I. Finally, we can print each value of the array with a space between them. What if we didn't know the size of the array? In this situation, we could use something called a for-each loop. A for-each loop acts similarly to a for loop, except it has a more limited use. For-each loops can only be used with arrays or collections, like array lists, and go through each single element of the array. They skip no values and traverse the array in order of index. The general structure for a for-each loop is as follows. The for keyword, the variable type, and a variable name, a colon, and the name of the array. You can name the variable whatever you'd like. Here's our last problem. Let's make a new array with the following line of code. Use a tab or 4 spaces between each letter in these strings. This question asks us to use a for-each loop to print out each element of string array. Then read the message that gets printed. You can pause the video here, work through the problem on your own, and resume the video once you have attempted or completed the problem. Here's the key. Just like the previous questions, we start by creating our array. This time, the array we're using is made up of 3 strings. Then we create a for-each loop that will go through our array. For each string str in string array, we'll print it on a new line. When the code runs, you should see the words "You did it" vertically in the console.
Hi, I'm Alexis. Thank you so much for watching and congrats on completing your 7th Girls in STEM lesson. If you have any questions, comments, or concerns, please feel free to reach out to us at our email, ccagirlswhocode@gmail.com, or comment down below. We wanted to thank the following for all of their hard work that went into today's lesson. All of the slides, videos, and problem sheets in this series are available on our website as well as the description below. I hope you'll join us again in our next lesson on methods.